one of the most powerful hurricanes of all time,
Never seen anything like it before, ever.
crashes ashore in 1989.
Look at those wind speeds.
Hurricane Hugo creates mayhem on the ground,
At the time, it was the costliest U.S. hurricane in history.
while in the air,
Can't get the left wing down.
Mother Nature's got a hold of my airplane.
Don't force it.
the killer storm is ripping apart a government research plane.
And she's taking it where she wants to take it.
We're losing number 3. I don't believe this.
Number 3 engine's on fire.
More power.
The pilot lost control of the aircraft.
That's all we're gonna get.
We started plunging downwards.
It's not enough.
I thought death may be coming.
The world is watching as Hurricane Hugo churns across the Atlantic. It's a massive cyclone, over 600 kilometers wide. The storm is marching steadily towards the Caribbean and threatens to hit land in less than 2 days' time. On dozens of islands and along the US seaboard, people rush to get out of Hugo's path. But high above the ocean, a team of hurricane hunters is doing the exact opposite.
Do you have 90? I've got 95 on this.
They're heading straight for the eye of the storm.
Whenever you're approaching a hurricane for the first time, you always have a little bit of that tingling, like anxious, what is this storm going to be? All storms have different characters. They all have different personalities, and a lot of times they can be pretty mean.
20 minutes up. Enjoy the sunshine while you can. Roger, enjoying sun.
NOAA 42 is a scientific research plane with the National Oceanic and Atmospheric Administration, or NOAA.
We had a who's who of hurricane scientists flying with us, some of the most experienced hurricane scientists in the world.
By flying into the storm, the scientists on board can precisely measure wind speeds, temperatures, and pressure, valuable data to help predict Hugo's path and ultimately save lives. Jeffrey Masters is NOAA 42's flight director.
It's my job to guide the aircraft into the eye. So I have to tell the pilot, okay, come left 10 degrees and change your track to this particular track.
Jerry, let's go with a track of 070 until we get a little closer.
So I was issuing commands to the pilot as well, studying the winds, making sure we were going to go right into the eye.
Turning to 070. Thanks, Jeff.
At the controls is Jerry McKim. A Navy pilot for 20 years, he's flown into 4 previous hurricanes.
People think we're crazy for flying into hurricanes, and not one of us have a death wish. Not one of us want to get hurt. We just do our job.
What are you thinking for speed?
Thinking we blast our way in. Let's try to keep it at 250 knots.
The flight's commander is Lowell Genslinger, one of the most experienced hurricane pilots in the world.
My 13th season, this penetration was the 249th penetration.
Since hurricane reconnaissance flights began in the 1940s, 2 US air crews have been lost. 17 people killed.
Yeah, I guess you probably would need to be kind of a maybe risk taker or something like that, yeah. But probably not everybody wants to do it.
The NOAA crew took off from Barbados in a P-3 Orion turboprop. It has the power it needs to penetrate the strongest storms.
It's a very tough airplane. It's a stubby wing with 4 big, huge engines on it. It's very, very powerful, built like a tank. It can take turbulence, it can take a beating and keep on ticking. So it's a good airplane.
The P-3s are flying laboratories, and they've got over $10 million worth of specialized weather equipment. So they've got the best sort of weather picture you can possibly get in the air.
45 minutes out from the storm, NOAA 42 is cruising at just under 10,000 feet. Scientist Frank Marks monitors his radar while preparing for the mission ahead.
We're flying out and we have a pretty good radar perspective. We can see, the eye was very clearly obvious, and we were focused on getting this experiment called the Hurricane Energetics Experiment.
The object of this was to study the storm's interaction with the ocean. And in order to do that, you need to fly at low level near the ocean.
The mission will require NOAA 42 to descend to just 1,500 feet above the water before entering the storm. 30 minutes behind NOAA 42, an Air Force Reserve C-130 is also heading for the storm.
Turn left now to track Hugo on heading 066. It will be hard to miss.
Robert Katz is the navigator.
We were told it was a major hurricane, and that's always just a little bit nerve-wracking and exciting at the same time.
The planes will work together inside the storm to get a more complete picture of Hugo's strength, so they can gauge how dangerous Hugo will be when it hits land.
If we stay on this heading, we should take it in nice and straight.
We were the first aircraft to go into the storm, and that always adds a little element of danger because the only way you know for sure how strong a hurricane is if you've actually had a flight go into it.
At the National Hurricane Center in Miami, Miles Lawrence is also watching Hugo closely. He needs to know what kind of warning to issue to those living in the path of the storm.
I was busy turning the crank back at the Hurricane Center, plotting the data on maps and entering it in the computer and trying to make my forecasts.
Hurricanes are among the most destructive forces in nature, causing billions of dollars in damage. Since 1983, they have claimed an average of 47 lives each year.
You can look on the satellite picture and see that, hey, there's something going on here. So we knew there was something going on, but was it going to get that strong? We didn't know that, not looking at a satellite picture.
Looks like we need to keep an eye on this one.
Go in, look around, go home.
That's the plan.
While they fly, NOAA 42 will transmit regular bursts of weather data back to the Hurricane Center.
There's an aircraft satellite data link. So every 30 seconds, it just takes a snapshot of what we're seeing with the instruments, and so they can see the progress of the storm.
They prepare to begin their descent.
Oh, crap.
A crucial instrument fails.
Guys, my belly radar just went down. Just come back and try that. Let me check the board.
The team is relying on 2 onboard radar systems to help guide the flight through the chaotic storm. The most critical one has suddenly gone dead.
Jeff, how's our heading looking?
Without their lower fuselage radar, the crew is now flying partly blind.
Yeah, just stand by, Lowell. We're just on our belly radar.
I have a nose radar. It's a C-band radar also, just like the belly radar, but it's not as powerful as this belly radar.
Yeah, okay, I'm coming up.
The nose radar didn't have as long a range, and we couldn't see the eye wall with it.
I'll just try to troubleshoot this. I'm going to go talk to the boss, all right? Hey, guys, sorry about that. Is it fixable? I think so. I mean, yes. Yeah.
Attaboy.
We got technicians and electronic engineers on the back that work it, and they have to reboot it or do whatever they do.
The mission is in jeopardy.
This is big science, big expensive science, and you don't want to screw up the science by, not going with the plan.
Until they fly in, neither crew will know exactly how ferocious the storm really is. But satellite images predict winds as fast as 200 kilometers an hour, the kind of winds no commercial airliner would ever attempt to fly through.
All we knew when we took off was it would be above a Category 3 hurricane. And for the aircrew, that always means a possibility of a good ride. That's the way we term it.
Hurricanes are rated on a scale from 1 to 5. A Category 3 means winds between 178 and 208 kilometers an hour. It can destroy mobile homes and cause major flooding.
The lower fuselage radar was out about 20 minutes, and we circled in place for that period of time, waiting for them to fix it. And that was about as long as we were willing to wait because we had limited fuel to finish the mission.
Nice. That's great. Hey, Hugo, it's good to have you back.
On NOAA 42, repairs are complete.
Lowell, radar's up.
Yeah, you could do it. Okay, no more excuses. Let's get in there.
Masters quickly evaluates the current status of the winds. The storm has increased in strength.
I watched the displays of the numbers, watching the winds come up, and I thought to myself, okay, this is probably not so good. I think maybe this is a little stronger than a Category 3 hurricane.
Forecasters on the ground also see signs that Hugo's winds are gaining strength.
How strong was it going to get? Was it going to reach Category 5? Were the winds going to get to 150 miles an hour? Or were they going to stop at 130? I had no idea.
This storm could do some damage if it makes landfall.
As they approach Hurricane Hugo, the crew of NOAA 42 prepares for their mission.
Unless anyone has any objections.
I'm good. I'm good.
Down we go.
They're planning to fly through the storm barely 1,500 feet above the ocean.
In a hurricane, the winds are strongest down at the low level, and we call it the planetary boundary layer. So if you're flying at 500 meters, you're right at the level where the winds are probably the strongest. That's 1,500 feet.
4,000 feet.
The low altitude is an ideal place to study the storm.
Steady as she goes.
But it's also a more dangerous place to fly.
3,000.
The lower you go into a storm, the more violent it is. At 20,000 feet, it can still be rough. It can still be violent. But it's not nearly as rough or as violent as down at 1,000 or 1,500 feet.
You don't have a big margin of error at all if you're at 1,500 feet in a hurricane. You can encounter downdrafts that'll drive you down at 500 feet or maybe 1,000 feet without the pilot being able to do anything about it.
Lowell, we are drifting.
The newly repaired radar helps Masters guide the plane into the wind.
Let's get over another 10 degrees left.
Roger, 10 degrees left. Track 080.
Turning left 080, coming right up.
After NOAA 42 enters the hurricane at 1,500 feet, the Air Force C-130 will follow them in at a much higher altitude, 10,000 feet.
They preceded us by about 30 or 45 minutes into the hurricane.
NOAA 42, this is Teal 57. Confirm your altitude through the eyewall will be 1,500 feet.
We always make contact with the NOAA airplanes to make sure that we coordinate our locations.
Teal 57, NOAA 42.
That's right, we are now descending to 1,500 feet.
Roger, NOAA 42.
Ladies and gentlemen, please fasten your seatbelts
And put your trays in the upright position.
set condition 1.
Condition 1 alerts the team to buckle up and brace for heavy turbulence. It will take 20 minutes to fly through the outer wall of the hurricane, with winds growing stronger and stronger until they reach the calm eye of the storm.
I was definitely on edge as we approached Hugo. I mean, this was a big, powerful hurricane.
NOAA 42 first enters the outer edges of the storm, long spiral arms made up of powerful thunderstorms.
Gonna be a bumpy ride.
Immediately, it gets dark, and you start hearing the hammering sound of rain on the fuselage. And the window gets streaked with rain, and you can see the wingtip start to bounce up and down, but you can't see very far. You're kind of in this gray cocoon.
Seriously?
It was very rough. We were being thrown around before we even got to the eye wall. Not to the point where we were out of control, we were just being thrown around.
Genslinger joins McKim on the controls.
2 against 1. Now it's a fair fight.
Yeah.
And the controls are connected, so when one guy would turn it to the left, the other guy is still on it too. So you're both doing a coordinated effort to try and keep the wings level and watch the pitch.
We don't see anything. There's no ground reference, there's no sky reference. You don't see anything. You're on full instruments inside the airplane, looking at your artificial horizons, your airspeed gauges, your altitude gauges, and whatever else tools you have in the cockpit to guide you.
The powerful winds are blowing the plane sideways. To counteract the wind and fly straight through the storm, the pilots must keep their plane skewed to the left at a sharp angle.
The winds are going counterclockwise as we're going into the eye wall. So they're coming from my left side. So I have to point the nose of the airplane into the wind to keep myself going on the same track. It's a very intense time in the cockpit.
So we were over, at least 45 degrees crabbing, which means we were tracking 45 degrees right of our center. So you got to forget where you're pointing to the airplane. You got to just think about where your track is going.
Lowell, we're getting off track. You've got to go left 5 degrees.
Roger, 5 degrees left.
5 degrees left.
This does it. Not too far.
We're in heavy rain. The wind is going up and up and up and up.
Despite the turbulent conditions, team members continue collecting data for the mission.
We were expecting a strong hurricane, so, the thought was, well, we'll follow the plan.
At the National Hurricane Center, scientists receive a burst of data from the planes.
Look at those wind speeds.
It reveals increasing wind speeds and dropping pressure inside Hugo, a sure sign that the storm is getting worse.
I think this storm's going all the way.
We were thinking in terms of a Category 2, 3 hurricane, and now we've got something which is almost a Category 5.
On board NOAA 42, Jeffrey Masters is coming to the same conclusion.
Hope I'm wrong. I really hope I'm wrong.
There'd only ever been one Category 5 hurricane in recorded history out this far east, and I had never been in a hurricane at that low an altitude and that was that strong.
A hurricane is classed as a Category 5 if it has sustained wind speeds of 252 kilometers per hour or higher. When they hit land, they can rip buildings clean off their foundations. Flying through one safely is the biggest test any pilot could face.
Let me off this ride.
McKim knows that turning around is not an option.
We don't do U-turns. Once we make the commitment to go in, we go in.
In such fierce crosswinds, banking his plane to turn could send it tumbling to the sea.
I'm having to point the nose more to the left as the winds are getting stronger and stronger.
Let the plane find where it wants to be.
I'm trying, but she doesn't know what she wants.
Suddenly, the plane begins banking dangerously to the right.
I'd never experienced anything like this. There was just kind of this big kind of thundering, shaking sound. The whole airplane just kind of quivered. I thought, maybe we were goners here.
I'm trying to pull back on the rudders, and I can't do it.
I can't get the left wing down.
Don't force it.
And I look at Lowell over there, and he's doing the same thing.
The sudden turbulence shakes heavy equipment loose in the cabin.
We had our 200-pound life raft break loose. Knives and forks from the galley are all flying around. Extremely dangerous situation.
We're in an angle of bank going down. At That next second, the number 3 engine fire warning light comes on.
We're losing number 3.
I don't believe this.
Number 3 engine's on fire.
I remember thinking, this is what it feels like to be in battle and to be shot at, and, you know, death may be coming.
Options?
Not many.
With one engine on fire, they're losing altitude fast.
It was coming out the tailpipe. Flames quite a distance.
We gotta shut it down.
Go.
If they don't shut the engine down quickly, flames could engulf the entire plane.
Emergency shutdown handle.
Pulling the handle starves the engine of fuel and douses the flames. But the loss of an engine has left them in a dangerous bank, and they're still losing altitude.
More power.
Airspeed's increasing because we're going down now, and we had all the power on the airplane, so we have our hands full.
More power.
That's all we're gonna get. Throttles are at the firewall.
It's not enough.
The pilot lost control of the aircraft, and we started plunging downwards toward the ocean.
The next thing that happens, bam. We're through the eye wall.
Oh, thank God.
Never been happier to see the inside of a Hurricane.
The crippled plane has made a narrow escape, emerging into the relative safety of the hurricane's eye.
It's just a big sigh of relief. We're in the eye, now what?
The air in the eye is calm.
We gotta climb.
Yep.
But NOAA 42 desperately needs altitude. They're less than 1,000 feet above the ocean.
No way you could ditch or anything because the waves were 60 feet high. And, you know, who wants to go down there? So you just wondered how, you know, we're going to be able to pull this thing out.
The only way out of the storm is back through it. But with only 3 engines running, re-entering the eye wall at this low altitude would be suicidal.
The hurricane hunters had never been through something like this before and survived.
Let's try to get her up to 6,000.
Their only hope is to try to exit the eye at a higher altitude where the winds aren't as strong. But with one dead engine and heavy with fuel, the plane is struggling to climb.
I thought there was about, I figured, a 1 in 3 chance that we weren't going to make it back.
There's another problem. The eye of the storm is less than 20 kilometers across. If they don't start turning, they'll fly back into the dangerous turbulence.
We had to immediately make a decision about how to turn to stay in the eye, because if we hit the eye wall again, we were probably goners.
NOAA 42 begins a series of slow spirals inside the eye. But the motion of the storm means they need constant corrections to their path.
You need to track about 2 points northwest.
Yep. Got it.
Nice flying, sir.
A hurricane like this wobbles. They don't go in a straight line. Each time we made a circle, the thing would move. You think a hurricane's going to move, it'll just go in one direction, you know, like it's moving, but it just wobbles.
Everybody in one piece up here?
Just barely.
You look around you and you're inside kind of a giant stadium. You can kind of see the clouds slowly rotating. It's the kind of this ominous marching of the clouds around you.
Now what?
Wait for the cavalry to arrive?
Works for me.
The strategy buys them time to figure out what to do next.
The only thing is, we didn't know what kind of shape the airplane was in as far as structural problems, you know, and that's nothing you could do about that. You just wondered, you know.
They also have no idea how much stronger Hugo will get. If wind speeds in the eye wall keep increasing, NOAA 42 may be trapped with no way out.
When a hurricane's undergoing its initial rapid intensification cycle, like Hugo is doing, sometimes it's able to concentrate its winds in a very small area right around the eye.
Their best hope is the Air Force plane still approaching the storm.
NOAA 42 to Teal 57, we've had an emergency, we've lost 1 engine.
The first thing that NOAA 42 said to us was that they had an emergency and they've lost 1 engine. And our airplane became very silent. I can remember just turning around, looking up at the pilots. They turned around, they looked back in our direction, and everybody was thinking, oh no.
The Air Force Reserve C-130 speeds towards Hurricane Hugo.
The NOAA 42, we're on our way.
Its crew is responding to a call for help from their endangered colleagues below.
There was not a whole lot that we could do. You know, we were in two separate airplanes, and we couldn't do a James Bond movie feature and extract them out one by one, so we were concerned for their safety.
Meanwhile, in the eye of the storm, Commander Genslinger spots another potentially deadly problem.
Crying out loud. Hope you're not too attached to engine number 4.
You're kidding me.
We've dealt with one emergency, now we got another emergency.
A strip of rubber is dangling from the front of one of the remaining engines. The de-icing boot is designed to keep the propeller clear of ice. It's been torn loose and could be sucked into the engine's air intake, putting the crew in even greater jeopardy.
And that engine's going to overtemp, and you have to shut it down, and that would have been disastrous.
If they lose 2 engines on the same side, there's no hope of making it back through the storm.
Going through the eye wall on 2 engines would be an impossible thing.
Once the C-130 passes into the eye, it might be able to fly close enough for the crew to assess the damage.
Teal 57, we're going to need a favor.
I don't know if we can climb high enough on 3 engines. You come down to us?
Roger, NOAA 42, starting our descent.
Well, they did sound pretty calm, but I was very unnerved by it, and I know our crew was unnerved by it. But they were trying to be as matter of fact as they could.
The crew now faces a critical decision.
We're too heavy to get much higher.
Want to dump some fuel?
Dumping fuel will make it easier to climb, but if they dump too much, they won't make it back to Barbados, more than 500 kilometers away.
I think we can spare 15,000 pounds. We won't be doing any sightseeing on the way home.
Prepare for fuel dump.
Okay, guys, shut off all the equipment, okay? Everything goes dark. All right, everything.
Their electronic gear could spark an explosion.
When you dump fuel, it comes right out of over the wing. If anybody's talking on the radio or got any emitters that might start a spark or anything, you could have a fire.
Fuel dump switch.
On.
There it goes.
We dumped it for 10 or 15 minutes, and we got rid of all the fuel that we could.
NOAA 42 took off with enough fuel for a 9-hour flight. After dumping 15,000 pounds of fuel, the tanks will be empty in about 4 hours.
My engines are still putting out the same amount of power, and now I've just lost weight, and now my wings, with the amount of lift that they're generating, can actually pull me up higher.
Come on, you piece of crap.
Above them, the Air Force plane powers into the eye of the storm.
Stand by, NOAA 42. We'll begin getting into position now.
To meet inside the hurricane, NOAA 42 needs to climb while the Air Force plane descends. The 2 crews must coordinate their airspeed and bank angle to keep from slamming into Hugo's treacherous eye wall. It's beyond dangerous.
NOAA 42, we see you.
Pilots would never risk doing this if lives weren't at stake.
We coordinated our positions, and once we saw each other, it was purely done visually.
No sudden moves. They're on us.
And as we got closer, we flew within about 1,000 feet of the other airplane.
One slight miscalculation and the 2 planes could collide.
The close flyby that the pilot of Teal 57 did with the pilot of N42RF in the eye of a Category 5 hurricane with a shrinking eye of only 10 miles diameter, one of the most remarkable feats of aviation ever attempted.
We tried to see if there were any panels missing. That would have been a big concern, because if a panel was loose and eventually broke away from the airplane, it could have gotten caught up in a propeller which would have been a very serious thing. They also had an engine fire, so they wanted us to see if there were any visible signs of fire still remaining. We didn't see any of that.
No, 42, you look like you're still in one piece other than that de-icing boot.
They eyeballed us and said they don't see any damage.
Moments later, there's more good news.
I'll be damned. The icing boot's gone.
Best news I've heard all day.
The de-icing boot has blown off without damaging the engine.
That was a relief to see that that thing's gone when it was.
Teal 57, we need another favor. We can't stay in here. Fuel's going to be an issue very soon.
Can you help us find a soft spot?
Roger that, we'll see what we can find.
We asked them very nicely, could you please go in and out of the eye wall of Hugo a couple different places to find a soft spot for us? And please do it at the altitude that we're maxed out at, which is 6,000 feet.
They were asking us for a way out of the storm. As a crew, we got together and we decided to go ahead and continue making our penetrations. Exiting the storm, we asked NOAA if they could delay in the eye a little longer, and they did that.
On board NOAA 42, there's nothing to do but wait.
We gotta get out of here.
And hope they don't run out of fuel.
Any word yet, guys?
No, 42, I think I have something for you.
The Air Force plane has found a possible exit point.
Try the northeast quadrant.
That was what we determined would be the better of the headings for them to try. It would be the best one with the least amount of turbulence for them.
Roger. Northeast quadrant. We'll see you back at base.
Let's hope they're right.
The crew prepares for a second perilous trip through the wall of a Category 5 Hurricane.
Things that we couldn't really strap down, we just threw into the loo and closed the door and figured they would just stay in there and rattle around. The most dangerous thing that we had coming up was the turbulence going through the eye wall again.
NOAA 42 is going to try to punch through the storm at 6,000 feet. They hope the winds at this altitude will be less destructive.
Site condition 1.
At that point, we really didn't have much choice. We were low on fuel. Our pilot said, we're going for it. Site condition 1, put on your seatbelts. We're heading out of the eye. We weren't confident at all that we wouldn't just suddenly have a failure and go splashing in the Atlantic Ocean.
We had to go through the rain bands and weave our way through the exterior parts of the hurricane.
We were very concerned on the flight back where we weren't going to make it.
The Air Force crew has chosen the exit point well. There's far less turbulence at this altitude.
That's more like it.
After a tense 20-minute journey back through the storm that nearly killed them, the crew finally escapes Hugo's powerful grasp.
The sun was shining above us, and I said, hallelujah, praise God, we're going home.
Oh, my God. What a day.
Yeah, a little too close for comfort, if you ask me. Teal 57, we're out, and I think we owe you one.
All part of the service. We'll see you guys back on dry land.
After their harrowing ordeal, Jerry McKim and Lowell Genslinger get their plane and everyone on board safely back to Barbados.
I don't think it sunk in until we got home or, what we really went through.
Now it's up to NOAA pilot and safety officer Terry Layden to investigate why a crew of skilled hurricane hunters was nearly killed on the job.
A lot's at stake that could be repeated if you didn't figure out why.
First thing I want to do, tear that engine apart.
Between September the 17th and the 22nd, Hugo devastates St. Croix. then tears through Charleston, South Carolina. The storm inflicts more than $9 billion in damage and claims 49 lives. But more might have died if not for the work of the hurricane hunters, who helped sound the alarm by accurately predicting Hugo's path.
Set condition 1.
NOAA 42 has flown safely through dozens of other hurricanes.
All right, guys, let's do this.
Investigators need to know why this mission was so harrowing. They begin with a close examination of the engine that caught fire.
We called in a Navy maintenance engineering crew from Naval Air Station Jacksonville.
Let me see that again.
These folks can pull an airplane apart, put it back together, and look at every aspect of it.
It's getting a little bumpy.
They suspect the severe turbulence somehow damaged the engine. But they don't know how.
Let me off this ride.
Data from a sensor in the cockpit reveals how severe that turbulence was.
Pulling a lot of G's in that cockpit.
The G-meter uses sensors to detect the aircraft's motion and calculate how much stress it's being subjected to.
I can't get the left wing down.
Don't force it.
The G-forces are some of the most powerful ever recorded in any hurricane, and far beyond what the plane was designed to withstand.
P3 can handle up to 3.5 positive Gs and 1 negative G. The G-meter recorded stresses of 5.8 positive Gs and 3.7 negative Gs.
But the question remains, did the severe turbulence somehow cause the engine fire? Investigators find an unexpected answer.
It had nothing to do with the storm.
Turbulence was not a factor in the fire.
They determined that the fuel control unit was the problem.
A broken sensor couldn't properly regulate the amount of fuel flowing to the engine. Navy records reveal that the same problem has been reported on other planes.
And as it turns out, the Navy has a history of this kind of problem.
When the sensor failed, it fed too much fuel to the engine, and it ignited into a stream of flames.
We're losing number 3.
I don't believe this.
It was just an unlucky coincidence that the failure happened during this flight.
It could have happened on takeoff. It could have happened en route to the hurricane.
We gotta shut it down.
Go.
It could have happened anytime. It's just incredible that it happened at the worst possible time.
Emergency shutdown, Lando.
Even though the storm did not cause the engine fire, it did damage the plane.
Hope you're not too attached to engine number 4.
You're kidding me.
The torn de-icing boot threatened to knock out a second engine, which would have led to certain disaster.
We were worried that it would get caught in the propeller and shut down the number 4 engine, but we got lucky. That didn't happen.
They wonder why Hugo contained such unusually strong turbulence. When the team studies all the scientific data from the flight, they find their answer.
No wonder we had problems.
The violent winds that rocked their plane were caused by an unusual weather phenomenon that's never been seen before. The eye wall of the storm was dotted with tornado-like areas called mesovortices, where wind speeds reached 320 kilometers an hour. NOAA 42 was unlucky enough to fly directly into one. Investigators are left with an important question about the future of hurricane research flights. When the next major storm hits,
And down we go.
how can they keep hurricane hunters safer when they fly into the eye of a storm? Investigators interview each member of the hurricane hunting crew.
We'd been in at 1500 before, and it was fine.
We weren't thinking about what could happen. We were making decisions based on past experience, based on past knowledge, not expecting the unexpected.
We didn't have long to look at the storm before the radar went out. Oh, crap. Guys, my belly radar just went down.
The broken radar system left them less time to evaluate the storm and made a stressful situation even worse. In hindsight, Flight Director Jeffrey Masters thinks the mission could have been made safer.
Set condition 1.
We should not have been going in at that low an altitude with a full bag of fuel.
We're too heavy to get much higher.
You want to dump some fuel?
When you start off a mission, you've got a heavy fuel load, and that puts more stress on the wings.
I think we can spare 15,000 pounds.
It makes sense to go in at a higher altitude and then maybe do the mission at a lower altitude later when you've got less fuel.
We go in, we look around, we go home.
That's the plan.
They were doing their best to support the scientific mission.
By doing the lower work first, it was decided that everyone would be fresh so that we could, get things over with early in the flight.
Steady as she goes.
But sometimes a little more discretion is warranted, and it would have been very helpful, I believe, in this case.
After this incident, NOAA made a number of changes to keep hurricane hunters safer. The first plane into the storm now flies in no lower than 5,000 feet, where the updrafts and downdrafts are much less violent.
I think that's a very, very good safety recommendation. After you kind of figure out what the storm's all about, then you can go in and do your hardcore, really, really nitty-gritty research and get that plane down where it can give you the numbers you need to ground truth everything and to make sure that everything you're doing is safe.
Lowell, radar's up.
They also ensure that crews always review the mission strategy before flying into a storm.
People have asked me many times why we keep flying in hurricanes. You've been doing it for 32 years. Why do you need to keep doing it? And I say, because every time I go there, I see something different. I learned something new.
Meteorologists hope the discoveries made by NOAA 42 will help improve hurricane forecasts and save lives.
It costs millions and millions of dollars to evacuate a mile of coastline. So if we can get, let's say, down to a mile, how magical would that be? That we only had to evacuate maybe a 10-mile strip and know that we are pretty darn good at doing that. I think that's a goal.
NOAA 42 was repaired and went on to fly into more than 30 hurricanes without another serious incident.
Hugo was one of those unforgettable hurricanes from an aircrew point of view. In my entire career, I've had a couple of hundred hurricane penetrations. I don't remember them all, but I remember Hugo.
I'll take more power.
I always think that I was up there for a reason. I was up there to do my job.
Go.
I think he did a fantastic job of handling the airplane.
Nice flying, sir.
And everybody on the airplane worked well.
Hang in there, guys.
We were in the wrong place at the wrong time, in a bad part of the ocean, and we're very lucky to be alive.
Oh, hallelujah.
Will it be A, B, C, or none of the above? Find out in the explosive new series that takes science out of the classroom and onto the streets, starting tonight at 9.